This is the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. The questions posed in this podcast series all come from automation technology users like yourself across the process and discrete manufacturing industries. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is, how can vision systems be used to inspect solids and liquids? To explain this, I'm joined today by Fernando Callejon and Felix Klebe from Omron, a supplier of automation technologies ranging from sensors and control and safety components to motors and drives, robotics, and power supplies. So, Fernando, to get everybody on the same page, let's start with the basics. And what technology components are most widely considered to constitute a vision system?
Well, first, thank you for having me here. It's a pleasure to help and answer those questions. So, talking about the basic components that are mostly used with vision systems. So, a machine vision system has five key components that can be configured either as separate components or integrated to a single smart camera. The correct configuration is going to depend on the application, the complexity of that application. But the five key components you're normally going to find, the first one is going to be lighting. This is critical aspect of machine vision, right? To illuminate the part to be inspected, allowing its features to stand out so the vision system can see them as clearly as possible. The second component would be lens, where we're going to capture the image and present it to the sensor in the form of light. The third component will be the image sensor, where we're going to convert light in a digital image for the processor to analyze. The next component would be vision processing, which consists of algorithms that are going to review the image and extract the required information for the inspection. And the last component, which is optional, is related to communication, where the resulting data is going to be communicated outside of the camera in a useful manner. Here in Omron, we separate all of our machine vision solutions in four main categories. You heard the first one, right? A smart camera. The definition of a smart camera for us is we're combining everything in a single device, all those components we just discussed. The next category will be vision systems, where the image acquisition is separate from the vision processing controller. The other category is PC-based cameras, where we're going to install the vision application software on the user's PC or industrial PC and connect the camera via Ethernet to that computer. And the last category will be industrial cameras, where in this case we're providing the camera only, where the user can visualize the image with a third-party software, or they can develop their own software application to inspect that image on a customer-provided PC. And on top of those categories, we also have to talk about vision accessories. So, and that list can be long. It goes on lighting, cables, lensings, input and output devices, enclosures, camera mounts, filters, polarizers. It's a long list.
Okay, thanks for explaining that, Fernando. So now that we've kind of established what the basics are of a vision system, which industries or types of products most frequently employ vision systems for automated inspection purposes?
First, I would like to identify the types of inspections we can do, and then I can give you more examples on the different application types per industry. So in terms of types of inspections, the first one, which is one of the most popular ones, it's quality inspection. And like the name is saying, right, we're checking the quality of parts. Sometimes could be just the presence absence. Sometimes could be just counting parts or checking the color or making measurements. The second type of inspection we play a lot is with recognition, validation, and verification. So in this one, we are recognizing characters or checking the quality of characters with OCR and OCD. We also looking for codes. Reading codes could be 1D or 2D codes, and we can actually check the quality of those codes as well. And the other type of inspection, it's localization of parts. So this one, we are with the camera, we are pretty much getting the position X, Y, and the angle of parts, and we're exporting that data to a motion system. Could be a PLC, could be a dedicated motion device, could be a robot, and could be even a 2D or 3D system. What we call the category as localization of parts. Then, in terms of examples for some of the target industries we support, so the first one we can talk about, it's automotive. Automotive, we see a lot of quality inspection, doing measurements or checking the quality of surface finishing, looking for specific patterns. I can give you like an example of those push to start buttons. That's a very common application for our cameras. Presence and correct seating of bolts in engine assemblies. A very popular one nowadays is also battery cell inspection is pretty critical with the electrification of cars nowadays. Color inspection in general, finish assemblies. Another one that's pretty popular is with fuse box inspection that we're checking the color of those fuses, location, and size of it. Another big industry is with packaging on food and commodity. So in packaging, we do a lot of label inspection where we're checking again for color, checking for position on the label, reading characters and verifying those characters. So, for example, date lot codes, expiration dates. Another one that is pretty common in industry is liquid level inspection for bottom lines. So we answered some of the questions already, right? Looking for liquid. Cap quality inspection, both before inserting the cap on the bottle or after inserting the cap. So we can check for measurement, contamination, liner presence on that cap, and if it's sitting correctly on top of the bottle. And another one that's it's huge on that industry, it's palletizing and depalletizing, where we're going to combine with our robot solution. So there's motion, there's guidance involved as well. For semiconductor and digital, we're huge on the PCB inspection. So PCB stands for printed circuit boards. So we're checking the quality for the components, the placement of those components, and also doing a lot of track and trace, reading the code of that board and letting the machine know and the operator know what is supposed to be on that board. And flat panel display alignment is another one that we do a lot for the LCD and LED displays. For material handling and logistics, we do a lot of character recognition verification for letter, text sortation, sort shapes in different categories, for example. And another big industry, that's one of the biggest ones we're playing, is with life sciences and pharmaceutical. A lot of presence and absence on that one, for example, for tablets, checking the labels, traceability of lab work, and another one's big one is package insertion and print quality. So those are big examples for all those major industries that we play.
And David, this is Felix. Just to add to Fernando's comments, as you see this huge range of industries, we have different challenges, not just in the types of inspection, but also the conditions. So you can imagine everything from the required IP protection to the ambient lighting conditions, and also a broad variety of differences on the inspection speeds that are required. So when we look at the different technologies that Fernando was mentioning earlier, we have different solutions that are possible in terms of sensor resolution, types of lighting, the logic that we have to control I/O on board in our smart cameras, and then also the software itself. When we look at a combination of encoded information in a barcode, comparing that to the results from an optical character recognition, allowing us to make sure that the information that's on the label is both accurate and consistent in terms of the type of product that's being produced or the packaging that's being selected for that particular label. So some of this analysis of the information that we're inspecting can be done right on board within the software, not requiring an external software application to complete that. So one of the things we really want to get across here is that we have the ability to provide a solution that fits best into all these different industries based off of the breadth of products that can be offered when it comes to machine vision.
Okay. Thank you both for answering that one. I appreciate that. So, given what we've discussed so far, what are the core criteria that users should consider when selecting a vision system or vision sensor for automated inspection applications?
Some examples of questions and things you should consider are like what are the needs of the inspection? You need to clearly define what is an acceptable product and what isn't. Set clear judgment criteria because you're going to use that when you're programming your devices. All of this could be part of what we call as a project scope. Another good question is will the expected object be moving or is it going to be stationary? Any specific speed required? So these could help select the type of image sensors that could be global or shutter type of image sensors. Or rolling shutter, I'm sorry about that. Do you have the space available to install the camera in your machine? Or will you need to design a separate inspection machine? This is one of the main reasons that a lot of users prefer to use smart cameras because they don't need to modify a lot the existing machine to install, for example, a more complex, powerful machine vision system. Another good question that you have to make is what is the available budget, both in terms of hardware and service? Why do I say that? Are you designing that internally? If you design internally, you could save some of the integration and service piece, but you need to check if your team have the skills to start the machine vision application. Some end users like to send their teams for product training before making decisions on which solution to pursue. Or instead of designing internally, you rely on your local partner, either a system integrator, a machine builder, to offer the complete solution. Another good one is what is the timeline of implementing a solution? These may help guide whether off the shelf or a customized solution can be created. These are some of the most basic questions, but other things to keep in mind are integration with machine controls, traceability and data storage requirements, installation environment. Do you need a specific IP rating? What is the skill set of your personnel? And always keep in mind about future scalability. Maybe right now you're just inspecting one piece, one portion, but you need to give an option to maybe install a second camera in the future, more lights, a special type of lens. So always think about the scalability for your future needs.
Now that we've established this baseline of what a vision system is, who uses it, what the key considerations in selecting one are, let's kind of get into the main reader question that drove this podcast. And the reader who submitted the question behind this podcast topic was looking for insight into how vision systems can be used to inspect solids and liquids. So, given that question, what are the major differences between inspecting solids and liquids for a vision system?
From the hardware and software point of view, you have very similar setups. The same tools will be used, just the way you use them might differ a bit. In terms of lighting, lighting always varies widely. For example, a transparent liquid level inspection would use normally a backlight, while a solid opaque label inspection would use more a direct lighting approach in most cases. Now, in terms of motion and how the product is presented to the inspection system, you might have some differences as well. For liquids, smooth accelerations and constant speed or velocity will help to maintain level and consistent product separation. So that's going to facilitate your inspection. Where in terms of solids, do not tend to change as much when you have your motion with the product or your motion profiles.
With any investment or expense associated with a piece of automation technology, there's always the question of justifying the investment and how that's handled. So, getting into the justification for vision system investment, what indicators for determining return on investment are most significant with vision systems, and where do the savings typically come from?
Yeah, that's a question we quite actually we receive a lot. But it might differ depending on the industry. But if I'm trying to summarize the most common ones, the first one is repeatability of inspection and consistent judgments. Less likely you're going to see products variation from different operators or other external conditions. The second one is one of the biggest ones is speed of inspection. So you're going to avoid the inspection line to be the bottleneck of your manufacturing line. A very common production bottleneck in number of industries, it is always the final inspection, or some people call it sensory inspection as well. Net content control and waste management, that's a big one nowadays. So you don't want to give away too much product, but also maintain labeled amounts to avoid other penalties. Labor costs, it's a common discussion, right? How can you repurpose inspection operators into higher level value added activities? So it's an interesting one nowadays with the current scenario, right? So you're going to be able to reduce human contact during current health situation. And another good one is initial capital equipment costs and engineer cost of implementation. That's a thing that you need to consider as well.
And David, this is Felix again. One other or a couple other considerations here are some of the softer benefits, such as speed of identifying the root cause of an issue. So some of these inspection results and being able to aggregate the data or use visualization software allows the manufacturer to much more quickly pinpoint the cause of a manufacturing problem and essentially get their system improved or tuned so that they're producing quality product again more quickly. So some of those savings aren't often considered on the front end of a project, but if we look at cost of downtime, the expense of that, cost of poor quality in terms of scrap, rework, and some of those other costs, which can be quantified, those should all be considered as benefits when you're doing your return on investment calculation.
Okay. Thank you both for that. And found it interesting that you mentioned that, Fernando, about the new requirements around COVID, how that now as actually benefits around that or of technologies that aiding in the distance issues is now part of an ROI around automation technology. So that's a thing that's a interesting development we're going to be seeing more of around automation technologies.
Yeah, yeah.
So, one final question I have for both of you here is considering all the work you've done with end users around vision systems, what recommendations for optimal use do you have? For example, what things should users be sure to do or avoid doing with vision systems to get the most out of them?
Sure. So starting with the do's, things that we really recommend you doing, right? Start simple and define a very clear project scope and solve problems one at a time. Don't try to find a solution for multiple defects at the same time. Go one by one. Start simple. The second thing is plan for scalability. How can we add additional functionality if we need it in the future? Do we have the physical space? Do we have to have compatible hardware, adequate resolution, and support for additional cameras? So all of those things you got to keep in mind moving forward. Another one is test as much as you can before making a full investment. Make sure you have adequate hardware and reliable results as compared to your typical tolerances, right? And document everything. Document your lessons learned from previous projects to avoid running into the same costly mistake and or setbacks. So always document all the lessons learned you had throughout the projects. And some of the big don'ts, avoid investing in multiple software platforms for the same application. Try to keep things consistent for engineers and operators and leverage your initial investment. Take advantage of the investment you're making from an engineer point of view so they can be consistent whenever they need to troubleshoot or support more the application. If you have never worked with a vision system, don't go it alone. Find a reliable system integrator or try to avoid mixing different solution vendors down the road. The more consistent the solution approach, the better. Using products which have been proven to work together, such as specific cameras and lighting, can help minimize interoperability and other performance surprises you might have when you try to integrate them.
All right. Well, thank you both for joining me for this podcast, Felix and Fernando. And thanks to, of course, to all of our listeners. And please keep watching this space for more installments of Automation World. Get your questions answered. And remember to visit our website at www.automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.